This next video contains word problems which involve proportions. Check the examples out here in Mathematics of Engineering. Before starting with the examples, let's review a little bit about continued proportion. These are the type which are related, such that the first is related to the second, then the second is related to the third, and so on. The first example looks for the parts of 70,000 proportioned as A is to B with 4 is to 2, then B is to C as 10 is to 5. Placing these proportions in fraction form, we see A over B is equal to B over C. Numerically, we show 4 over 2 is equal to 10 over 5. With B relating both proportions, we use it to find equivalent proportions. That is done by taking the least common multiple of B. The LCM of 2 and 10 is 10. Then find the equivalent fractions with 10. First is 4 over 2 transformed to A over 10. 2 is multiplied by 5 to be 10. So A is then 4 times 5, which is equal to 20. The second proportion is 10 over 5, which should be transformed to 10 over C. 10 is still 10, so C is still going to be 5. Thus, the final proportion of the three would turn as 20 is to 10 is to 5. Now to take the parts from 70,000, we use partitive proportion, where we need to add all proportionals 20 plus 10 plus 5. That is equal to 35. One part of 70,000 is then computed as 70,000 over 35, which is 2,000. So A is 20 times 2,000, giving 40,000. B is 10 of 2,000, which is 20,000. And C is then 5 times 2,000, and that is 10,000. For the next example, divide the number 49 into two parts where the greater numbers increase by 6 related to the smaller number decrease by 11. And this is proportioned as 9 is to 2. We start by assigning variables for the unknown numbers. Let's assign x for the bigger number. Then the smaller is taken as 49 minus x, as the premise states that the number sum is 49. Next is to interpret the proportion. It states that 6 is added to the bigger number, and this is to the lesser number less 11. This is proportioned as 9 over 2. Simplify the terms to get x plus 6 over 38 minus x as equal to 9 halves. With cross multiplication, simplify the proportion into twice of x plus 6 as equal to 9 times 38 minus x. Multiply the factors and get 2x plus 12 as equal to 342 minus 9x. Transpose similar terms to get 2x plus 9x as equal to 342 minus 12. This is then taken as 11x as equal to 330. Isolate x by dividing both sides by 11 and get x, the bigger number, as 30. The smaller number is then taken as 49 minus 30, or that is 19. We move to example 3. Determine two numbers whose product is 135. The difference of their squares is to the square of their difference, as 4 to 1. We assign x as the larger number, and y as the smaller number. The first premise is the product xy as equal to 135. So y is then equal to 135 over x. For the second premise, the difference of the numbers' squares is shown as x squared minus y squared. This is in ratio with the square of the numbers' difference. That is the square of x minus y. This proportion is equal to 4 over 1. Having identified the proportion, we use cross multiplication to get x squared minus y squared as equal to 4 times the square of x minus y. Next is to create an equation with a single variable, and that is by placing 135 over x for all y's. So the equation becomes x squared minus the square of 135 over x as equal to 4 times the square of x minus 135 over x. Expand the square to get x squared minus the square of 135 over x squared as equal to 4 times x squared minus twice of x times the last term, 135 over x, then add the square of 135 over x. At this point, cancel x in the middle term of the expansion to have x squared minus 135 squared over x squared as equal to 4 times x squared minus 270 plus the square of 135 over x squared. Take out the brackets and get x squared minus 135 squared over x squared as equal to 4x squared minus 1080 plus 4 times 135 squared over x squared. With a simplified equation, create a single fraction on either side by taking the LCD, and that would be x raised to 4 minus 135 squared all upon x squared. This is equal to 4x raised to 4 minus 1080 x squared plus 4 times 135 squared. And all three terms are upon x squared. Cancel the denominators, then collect similar terms, and get 3x raised to 4 minus 1080 x squared plus 5 times 135 squared as equal to 0. This is then equal to 3x raised to 4 minus 1080 x squared plus 91,125. Divide everything by 3 to get x raised to 4 minus 360 x squared plus 30,375 as equal to 0. With the exponents of 4 and 2, we can still use the quadratic equation to figure out x squared, making negative of b, which is negative 360, plus or minus the root of the square of 360, minus 4 times 1 times 30,375 upon twice of 1. From the long equation, the first x squared is then taken as 360 plus the root of 360 squared minus 121,500 over 2. This gives x squared as 225. Take the square root to have the first value of x as 15. The next value of x squared is taken as 360 minus the root of 360 squared minus 121,500 over 2. The square of x sub 2 is 135. Again, take the root and have x sub 2 as 3 root of 15. With the two values of x, let's filter our answers. Try x sub 1 as 15. Thus, y is then 135 over 15, which is 9. Knowing these values, let's check the proportion. 15 squared minus 9 squared over the square of 15 minus 9 as equal to 4 over 1. This is simplified as 225 minus 81 over 36 as equal to 4 over 1. Then we get 144 over 36 as 4 over 1. We get 4 over 1 just the same. Now try the second value of x as 3 root of 15. Y is then taken as 135 over 3 root of 15, which is equal to 3 root of 15 just the same. Now check the proportion and get the square of 3 root of 15 minus the square of 3 root of 15 over the square of 3 root of 15 minus the same 3 root of 15. Note that all terms in the numerator as well as denominator cancel out, which makes the proportionality false. Thus, x is taken as 15 and y is 9. The next example states, divide the number 24 into two such parts that their product shall be the sum of their squares as 2, 3 to 10. Assign the larger number as x, and the smaller numbers taken as 24 minus x. In the proportion, the numerator is the product of the numbers x and 24 minus x. The denominator is the sum of their squares, x squared plus the square of 24 minus x. This is equal to 3/10. Expand the terms and get 24x minus x squared over x squared plus 24 squared minus twice of 24x plus x squared. This is simplified as 24x minus x squared over 2x squared minus 48x plus 576 as equal to 3/10. Cross multiply the terms and get 10 times 24x minus x squared as equal to thrice of 2x squared minus 48x plus 576. Distribute the exterior factors and get 240x minus 10x squared as equal to 6x squared minus 144x plus 1728. Transpose all terms to the left and get 16x squared minus 384x plus 1728 as equal to 0. Divide everything by 16 and get x squared minus 24x plus 108 as 0. By factoring, the equation is then grouped as x minus 6 and x minus 18, where x sub 1 is taken as 6 and x sub 2 becomes 18. As both numbers should add to 24, we can easily identify that x as 18 is the larger number. The smaller number is then solved as 24 minus 18, which is 6. For example 5, 20 is divided into two parts which are to each other in the duplicate ratio of 3 to 1. What number is a mean proportional between those parts? Assign x for the larger number, and the smaller number is then solved as 20 minus x. The proportion is also written as x over 20 minus x as the duplicate ratio, which is 3 squared over 1 squared. This is simplified as 9 over 1. Create the one-liner equation through cross multiplication, giving x as 9 times 20 minus x, simplified as x equal to 180 minus 9x. Transpose 9x to the other side and get 10x as equal to 180. X is then computed as 18. Then y is 20 minus 18, giving 2. For the mean proportional, the numbers is written as 18 is to m, as m is to 2. In fractional form, we get 18 over m as m over 2. Again, by cross multiplication, there is m squared is equal to 2 times 18. Take the root of each side and have m as 6.